Now, how do we convert the coordinates? So from the vector unit, we already know x equals to what? R cosine theta. Y equals to R sine theta. What about the radius? Radius squared, isn't that equal to x squared plus y squared? Pythagorean theorem. And how do you find the theta? Remember, it was arctangent of y over x. So we can use these four formulas to either go from polar to rectangular or rectangular to polar. So let's start from polar to rectangular. That's easier than going from rectangular to polar. So they gave you r and theta. So what would you do? Just use these two formulas. R is 2. So 2 cosine theta is pi, comma, 2 sine of pi. How easy is that? Yes, of course. So what is cosine of pi? Negative 1 times 2 is negative 2. Sine of pi is 0. 0 times 2 is 0. So this is rectangular coordinate. Let's see whether it is true. Let's roughly graph it. So you hear pi is over here, isn't it? Pi, 180, pi, and radius is 2. So in a rectangular coordinate, isn't it negative 2 comma 0? Yes. What about here? So again, r is root 3, so it's root 3 cosine of pi over 6. Root 3 sine of pi over 6. So if we roughly graph it, root 3 is less than 0.5. No. Root 3 is what? So root 4 is 2. Root 1 is 1. Root 2, we don't know. Root 3, we don't know. But we know it must be closer to 2 than 1. Do you guys see it? So it's like greater than 1.5, which is 1.7-ish, 1.7. So, but here we can just leave it as the exact answer. What's cosine of pi over 6? Pi over 6. Yeah, so it is root 3 times root 3 over 2 from the unit circle. What's sine of pi over 6? Root 3 times 1/2. So what's root 3 times root 3? You get 3 over 2. And here you get root 3 over 2. So you can leave it as the exact, you don't have to put decimal answers. So let's roughly graph it. So here at pi over 6, I have it here. And root 3, which was 1.7, let's say was here. And it turned out to be what? Both positive. First quadrant must be both positive. Okay? Any questions? So again, polar to rectangulars are easy because you just got to remember these two things. And of course, you need to know the unit circles. But now, when we go back to polar from rectangular, it's a little more complicated. Okay? Always go ahead and roughly sketch it. So where's negative 1, 1? Second quadrant. So what do we do to find r? You have to use the Pythagorean theorem. So this is negative 1 and 1. So if you're looking for r, what do you do? R squared, remember, equals to negative 1 squared, which is 1 squared, and 1 squared, which is 1 squared. So I get r squared equals to 1 plus 1, which is 2. So we get square root of 2. So it's square root of 2. And square root of 2 must be closer to 1 than 2. I believe it's 1.4. Can you guys check it? What is it? 1.4? So it will be somewhere here, right? 1.4. And what's the theta? What do? You can do arctangent of Just go ahead and find the reference angle and you will subtract. It's on the second quadrant, so you will either subtract or add. Right? So arctangent of y, which is 1, x is also 1. Just put the positive numbers because you're going to just find the reference angle. It's not going to always give you the right angle on these quadrants for tangent, second and third. So just go ahead and use the reference angle. What do you get? You get 45. So does that mean we put 45 there? No, this is 45, meaning what is this then? It is 180 minus 45, which is 135. So we get 135 degrees. So let's go ahead and plot it. So it is 135, which is 45 on the second quadrant. And it's 1 point, was it 1.4? So that's where it goes. Okay? Second one. So 0, 2. That must be easy. Why? Because it's either on the x or y axis. 0, 2 is here, right? Then what's the radius? 2. What's the angle? 90. Or check it, guys. What's arctangent of 2 over 0? Oh, it actually becomes undefined. So this one, you have to graph it and use your graph. So it's 2 and 90. So if this was 1, 2, 3, 4, you get 2 and 90.